Okay, upload your assignments first. Then later we will do the presentation. We won't be the first. It really doesn't matter. Do that in English. It'll be better. Okay, assignments, standard grading, graded. So Jay, Rachel, and John. Steve? Already uploaded? Okay, let me see. Where's Dylan today? Dylan or Dylan? Dylan. Okay, where's Dylan today? It's coming soon. Okay. Who won't be this first? Volunteer, any volunteer ask. Okay, Steve. Well, let me go to this grading, then, okay, then I'll download it, yours, okay. I think I need to close this one. Let me, I wanted to see this part, I think we can, yeah, then I can download it, yours. This, yeah, here, okay. Then, let me download one by, oh, okay. Just turn it on. Here? Yeah. All right? Just
Okay.
It's your turn.
I can use this.
Okay. It's your role to play. Okay, let me sit over here. We just started. Dylan, you upload your assignments first, okay? At the same time, let Steve do the
Hello.
presentation.
Hello. Okay. Hi guys. So I'm going to present my assignment.
Hey, speak louder.
Oh, I'm going to present my assignment. So the first part is just to download data, and the second part, we use hours. Wait, here, hours as our dependent variable, and all the others, age, education, blah blah blah, are our explanatory variables. Here. And as you can see, there's some signs here, which is our, which is my. Just a second. Oh, okay. Which is my basic assumption about the beta sign of the explanatory variables, and for age is negative, because I expect, just like Professor said, the younger they are, the longer working hour they have, and the education is positive because the more they were educated, they should be have are able to work longer according to the knowledge they have. And do I need to one by one explain one by one?
You can explain it later on with your
Okay.
output.
Okay.
Okay.
Okay. So the third part is the regression model, the result, and yeah. Notice here, we have I set the hours to be greater than 0 because if the working hours is shorter than 0, then there will be no meaning because time cannot be negative. So there's only 428 samples, and these are the coefficients after running the result. And as you can see, the R is around, adjusted R square is around 0.315, which is not high. And okay, and so the first one, the alternative hypothesis is smaller than 0, just like I said. And the second one, education, should be positive. And the third one, experience. Oh, labor market experience. The experience should be positive. Labor market should be positive because the longer you work, you should able to know your stuff better, and then they will hire you for longer. The family income has no has like you cannot say it's more better or less better, so that's why it's two-sided, related to working hours, because you can have low income while you have high working hours at the same time. Depends on what kind of job do you have. Maybe a high skill job or a low skill job. So for father education, I think it's positive. The same reason as the education. Basically, I think all the education should be positive, and the age is same as the first one, so it's still negative. Wait a minute. Isn't it? Husband. Oh, okay. Sorry. Sorry for the education part. For this part, it's positive. This one is positive because we're talking about women's working hours. So if her father is educated, I think she will have more knowledge to work as well, because when she was young, her father are able to teach her more stuffs. And for husband education, it's not related because it's about love, like it's about their habits, so has nothing to do with their working hours. That's why it's two-sided. And this one is husband working hours, I think. Okay. For this one, for the husband working hours, it should be Well, I think sometimes it's two-sided. Negative.
Well, I think some of the variables, really, you can find the reason to explain whether the alternative is one-sided or two-sided.
Yeah.
Okay, but according to my questions, okay, would you please show up all this variables list? Yes, the reason we wanted to put the signs here, okay, the signs here means our expectation,
Mm-hmm.
okay, and the expectation is according to the literature review. So all of this, if I put the sign here, means according to the literature review, it's already, it's more popular to say it is positive sign or negative sign. So although, if I didn't put the sign here, you can find reasons to support your alternative.
Mm-hmm.
Okay? So whatever I already put the sign here is already fixed. But the alternative would be the according to our literature is negative. So now if you run all this output, okay, with all the signs here, you need to see the result follow the expectation or not.
I think no.
Okay?
I mean, because you put this because of literature review.
Yeah. What I mean is literature review.
Yeah, but isn't it like sometimes this is not necessarily true?
Yes,
Oh.
of course. You always can find the reason to see which side. Okay, which side. Maybe you're saying that.
But I think like if they have literature review, maybe they have a.
Let's just pretend that all this science here is
Oh, okay.
our hypothesis, our expectation means it's already fixed.
Okay.
I mean the direction. The hypothesis, alternative hypothesis, direction is
Oh,
already
I see.
fixed. And those without the science means, you can do the both sides, two-sided. This is what I mean. This is what I mean. If you don't do that way, no, it's okay. I can see your
Oh, okay.
explanation, your justification. I think this is graduate students, right? There's nothing really fixed.
Okay.
Okay, as long as your justification is fine, then it's okay.
Okay. So for the hours, it says negative, and well, I think it's both sided. And for husband, hourly wage. I think it's related with this one, so that's why it's both negative. And for number of kids between between ages 6 and 18, it has no specific relationship with woman's working hour, so it's two-sided. And the number of the kids under 6, age of a 6, is negative because this one before the age of 6, maybe women need to work in the house and then take care of their child. So the working hour will be less relatively. So that one makes sense. And the mother's education is the same reasoning as father's education. So they are both positive. And the federal marginal tax rate facing a woman. Tax rate. The tax rate. Yes. Okay, okay. So, okay. So I think for this one, if you have, yeah, just like Professor said, if you have a higher income, then basically, if you have higher income, you will have higher tax. And if you have higher tax, that means you're doing a skilled job, which cannot be substitute. So in that case, the working hour will be shorter. Because if you have absolutely no skill, you are working in a factory like a machine, then maybe you need to work long hours instead. So that's why it's negative relationship. And the employment rate, the unemployment rate, I'm not sure whether this one has to do with the woman's working hour.
Put it a negative sign. So how do you
Mhm.
explain it? With the
Well,
how do you justify the relationship with unemployment rate and then hours?
uh,
This is all
oh, okay,
economics,
okay. Yeah, well
economic
then,
sense.
it's if the unemployment rate is higher, which means the woman has no job, or in general they have no job, so that's why the working hour will be lower because they get fired if the employment rate is high, so that's why it's negative.
Yeah.
And the wages has nothing to do with has low has no specific sign for working hour. Okay, so here's the result. And we can see from here for a little bit the probability. If it's 0.0000, then that means that just straightly means that the variable is highly related with the women's working hour. For example, like wage, MTR, and H wage, husband wage, and husband working hours, and experience, the labor experience.
Does all the signs follow our expectation?
Yeah, I'm going to check it here.
Yeah, okay.
So here's the hypothesis part, and if we set the confidence level to 95%, then this is the number 1.645 for one-sided test with 428 sample size, and this is the two-sided.
Well, since in our output with the p-value, you may
Actually,
you,
I will.
you can just see this probabilities compare with the using the p-value approach.
Yes, but as you said last semester, the p-value approach is harder than the t-value approach.
Is what?
It's harder than t-test.
It's harder.
Harder.
It's harder.
Yeah.
Well, it's really just in last semesters.
Oh.
So here we are saying that we already understand all this hypothesis testing. So it's easier. I mean, it's easier to just look at output and see whether the variable is significant or not. And also, there's a sign is follow our expectation. I think whether the sign follow our expectation and the probability is significant or not is the most important things we have explained it. And just, we just look at output.
Actually,
and explain it according to your output.
Okay, all the signs are correct with
Our expectation.
yeah with
You
yeah, including the both side has nothing to say, but except the both side.
You mean all significance, and also the significant. You mean look at the signs.
Oh, yeah,
Does that follow our expectations?
Yeah, I'll check it here. Here. Oh, not an education.
Yeah. So for the education, it doesn't follow our expectation, right?
Oh, okay.
And what else? Anything else?
Okay. And further education.
For presentations purpose. Okay, for the presentation purpose, it's better to not move your uh, your I mean what you have done, up and down.
Oh.
Just look at the output.
Oh.
Just look at output and tell us which one doesn't follow our expectation.
Oh, okay.
The sign, according to the sign, okay? Then after you see whether the sign, if they don't follow our expectation, look at the probability. Look at the probability whether it is significant or not.
Oh, okay.
Then you can double check. Okay. The first one, double check
So
the expectation.
the first age has the same with our expectation, and the second one, education, has the opposite with our expectation, which is negative. However, the probability here is not significant enough to reject the null hypothesis. So, which means that the second one is not a important factor, and the third one is an important factor which align with our the assumption. And the fourth one is both sides. So it's still it's not you cannot tell from the signs, so you have to tell from here. This number t statistic right here is significant enough because it's higher than 1.96. And the further education is the opposite with our expectation. So and if we check the probability, then it's not significant enough to reject the null hypothesis. And for the age, yeah, I forgot about this one. Sorry. Oh, negative. So it's the same with our expectation. However, it's not significant enough because of the probability test. And the education. I think it's both sides. Yes, both sides. So it's a both sides, so we cannot tell from the signs.
Is your both sides follow
Yeah.
our expectation?
Yeah, I think so.
Okay.
Yeah, here, nothing.
Okay, all right.
So the we have to see from here, and as you can see, the probability is very high, so it does not pass the p-value test. And for H hours, it's negative, and it's the same with our expectation. And if we check the probability, it passed the p-test and t-test. And the husband wage, here we have the negative. I think it's negative. For husband wage, we have negative sign, and it's passing the P and T test as well. And for kids age at between 6 to 18. Okay, that's a both side. For number 10, it's a both side. So you cannot tell from here. Okay, yeah. But it's not significant enough. It does not pass the t-test. And for the kids before smaller than age of 6, we expect is negative, and it is same with our expectation, and it passed the t-test as well. So that one is significant. And the mother education, education is positive, however here is negative. But if we check the p-test or the t-test, it does not, the factor is not significant enough. And the MTR, the tax rate, we expect is negative, and it is. It passed the P and T test, so that means MTR, this factor is highly related with the dependent variable, and the employment rate. Unemployment rate should be negative, and it is negative. So if we check the P and T test, it does not pass on 95%, but it will pass on 90%. So it's still not significant enough in our standard with a confidence level of 95%.
Just
Yes.
a second. Unemployment rate.
Yes.
We do have sign. We
Yeah,
we
negative.
we do have negative
Yes, here.
relation, right?
Yeah.
So what's the probability p? What's the p value?
It's 0.1305.
No, it's negative signs. What do you mean? What do we mean by if we have the directions? What's the p value?
Here?
Yeah. The p value always shows both sides,
Yes.
and this is negative signs. So what's the p value?
It's negative 0.1305.
This is for both sides.
Oh, you mean the p value is?
Yeah, it's for both
Oh, sorry,
sides.
sorry. Okay,
Yeah.
so it's
Yeah, that's
0.6.
this is key, right?
652.
Right, you need to divide it by 2. All the p-value from the output is two-sided. But we expected the negative signs means the p-value should divide it by 2. So it is significant by
Wait, it is? But
10%,
oh, okay.
right?
Yeah.
Right?
Yeah.
It is 10%.
Oh, yeah. Because my way, I usually just look at the p-value first, and if the p-value is too close to between 0.0
But
to 0.1,
yeah.
then I
Right.
will just look at the
Well,
look at the T.
we really have to look at the p-values, match that with our expectation. If it is one-sided test, the p-value should divide it by 2 in order to know whether it is significant.
Okay.
Okay?
Okay.
I think that's the key, and that's very important. All right. Go on.
Okay. So yeah, as Professor said, you can just divide it by 2 and check if it's greater than 0.05 or not.
Well, not really on a point of 5%. Usually we can use 10%.
Oh, yeah.
Right? As long
Wait,
as it is less than
are we
10%.
using 10% in this case?
Well,
Oh,
we
it
really
depends.
didn't say that usually 1%, 5%, and 10% works
Okay.
for everything.
Okay.
Okay? So you can see if in this case it is passed by 10% level of significance.
Okay. And for wage, it's both-sided. It's two-sided. So we have to check the significance, and here, which is significant enough to
Yeah, okay.
to the dependent variable. So here I just write.
Are you going to use the one class to do the presentation? For me?
Oh,
It's-
okay, I'll do
it's
faster.
too long.
I'll do faster. Okay.
Yeah.
So here, 2, 5, 12 have the wrong sign, and then 1, 6, 14 is do not reject null hypothesis, and this do not reject too. So at the end, here, I just list out from
Yeah.
3, 4, 8, 9, 11, 13, 15, reject hypothesis, which is blah, 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 blah. Okay. And the fourth question, run the pairwise correlation, and this is the result. So since it's kind of like symmetric, so you can draw a line from here and then check the numbers below or on the top. It's fine. I check from below, and the numbers that I are trying to find is greater than point. The absolute value will be greater than 0.7, and here only have two numbers that's greater than 0.7, which is age and a husband age, which is factor, which is beta 1 and beta 6, and for Fleming and MTR, which is beta 4 and beta 13, have the high correlationship. And in addition, this one is very close to 0.7. The absolute value here is very close to 0.7. So I also circle it. It's edge wage, which is beta 6, and MTR beta 13. Well, it's the same. It's the same betas. So they are highly correlated. Okay. So according to eView's result, these two combos have pairwise LoRa, and here it's just like I said, and partial correlation cannot be run on eViews, but I think can be run on Python. Okay.
Keep it.
Oh, okay. And run the auxiliary. So here's the auxiliary regression. The first one, second one, third one, fourth one. I just circled the high number, the number which is that's the should be the bottom one, but which is greater than 0.7. I will circle it. And the Fleming, this is the first one, and then this is the fourth, beta 4 and beta 6. So it's the same result with our pairwise
Okay.
correlations.
Mm-hmm.
And here 13, beta 13, and all the other are just normal. So it's the same, and it proves again that these four variables are highly correlated with each other's with the rest of the explanatory variables. And the VIF, here we look at the center VIF, and the number who's greater than 5 will be suspected to have a multi-collinearity, which is number 1, number 4, and number 6, and number 13. It's the same. So here, these four variables are highly correlated with each other with VIF. And the remedy is to drop the redundant variable and do the regression again. But I think there's some problem here. I'm not sure. So that's why I'm going to ask Professor. So after I dropped those variables, I got, no matter how I dropped it, I got lower adjusted R square, like in every kind of combination.
Well, you mean when you drop any, you try every, all the adjusted R square reduce. Why?
Huh?
Why the adjusted R square reduce?
Yeah, I don't know. Like
you don't know. We learned it.
It should be high. Oh.
We learned it last semester.
Oh. Wait, last semester?
Adjusted R. What's the difference between adjusted R square and R square?
Oh, because the x variables?
Maybe. I don't know whether you know that or not, okay? For adjusted R square, okay, I will say it again here, okay? For adjusted R, for R square, whatever variables put into the model, okay, whatever, if it is nothing related to y, but you put it into the model, the r square is always increased. But increase just a little bit. If you put any irrelevant variables into the model, the r square will always increase. And the increment of the r square cannot adjust the number of the x variable in the model. Okay? But adjust the r square. They consider the number of x variable into the model. Therefore, they can see if you include one irrelevant variable into it, r square increase, but adjusted r square decrease. Okay? That's why when all the multiple regressions, we all look at adjusted r square. If you include those important variable into the model, then adjust r square will change that much. Okay? All right? And that's why we're saying adjusted r square, when you take out all some kind of variables, the adjusted r square, of course, decrease.
I thought like the remedy was supposed to increase the adjusted r square. Or not, if we fix the multi-collinearity problem.
Well, compare with the original one.
Yeah.
Right? So
The original
this
one
is the 29.
Yeah.
What
The original one?
this is the original one.
No, this
20,
the original one is 0.33 and 0.31.
Adjusted r square.
0.33
Okay,
for r square, 0.31 for
let me
adjusted r square.
mention one thing. As long as your t values, these t values, as long as it is greater than 1, the adjusted r square increase. The adjusted the t value was 1. It may not be significant, but adjusted r square increase. As long as the t value is greater than 1. So many, according to the experience, okay, if your t values greater than 1, even the variable is not significant, maybe in the literature that is also important variables, but not significant. It doesn't mean that all the p-value is not significant. You can drop it out. That's why we're saying that what kind of variables we should include in the model is by reading the literature. Make sure all the variables are important. And as long as it is very important, according to many literature reviews, never drop it out, even it is not significant. Understand what I'm saying here? That's why reading the article is important. The variable, whether it is significant or not depends on the output. It depends on the literature review. Okay? That's very, very important parts. We're not using the output to select the important variable in the model. That's not the reason. Okay?
So with this kind of remedies, should we drop all 4, like beta 1, beta 4, beta 6, beta 13, or we only need to drop the one that's not significant?
Well, there's no
specific
solutions for this one, but you have to justify your reason.
Oh, okay. So I dropped these 2 because the beta 4 and beta 13 have are significant to the.
So beta 1 and
result.
beta 6 is what?
Is
One is your
relatively.
education?
No. Sorry. I'll move.
What do you mean by beta 1?
The age. Here.
Okay.
The age and
You drop age.
yes, and
And
6 is husband age because they are not significant. And the beta 4 Fleming is significant, and the 13 is definitely significant. That's why I drop only those two.
okay, all right, okay. Yes.
Should we also consider looking at it if we're going to drop the variable? For example, if you're going to use this for HR and you drop the age, wouldn't that cause issues?
Yeah, in that case, if I were working with this problem, I think age for women's hours is important. So I will not drop age. I will drop a father's education, because father's education is, that will affect children's education. Okay, so in that case, drop out father's education is better, much, much better than both of them. I will just drop one, which is father's education. I will keep.
Father education has no multicollinearity problem. It just significance
Well,
problem.
Well, those consideration, okay, yeah, let's always remember one. For multicollinearity, is the problem of multicollinearity is samples. Is according to the sample. If you have some other chance to collect another set of sample, maybe your age variables is important.
Oh.
All the relationship can be, very different. Okay? So since we just have one sample, we're not able to get another one. So when we consider, so there's why there's no specific answer for these questions, but your explanation, your justification is important to help you to get to the final solution. Okay? And according to the literature, I think women's hours working is really correlated with the age. So I will never drop the age variables. But I will drop father's education. Okay?
So, if the question is focusing on the remedy of multicollinearity problem, so do I just drop beta 4, or I just drop beta 6?
Beta 6 is father's education.
Wait, no, it's
Is what?
it,
Husband's education?
husband age. Age. This one.
Husband age.
Yeah, this
Okay.
one.
Husband age. Well, with different
don't-
combination of the x variable, so the result will be different.
Yeah.
Okay, so if I think, since I have, there's no age here, right?
Yes, I dropped.
With woman's age, I would drop husband's age, because woman's age is also important for the woman's hours.
Oh, okay.
But husband's age may related to the woman's age. So I will drop husband's age. but
even though
not-
it's significant.
Yeah, but not woman's age.
Okay.
Okay? I think this is kind of training, there's no specific answers for these questions. That's is why we need to have the practice. Okay?
Okay. Thank you, Professor.
Okay.
Okay, so for the last part.
Yeah, okay. Second two. Problem two.
There's just a slightly different, and I change it to x1a so that we are able to see the difference.
Yeah.
Easier.
Just this two number change.
Yeah. It
Yeah.
was
Thank you, Rachel. Help
x1.
me to change that. When I made this one, I used the same set, the number of.
So the difference is only coefficient and statistic, because the R squared and adjusted R squared are very close. And so the only difference I spot is coefficient. Well, they didn't change sign. They have slightly changes, but this one, the t-test statistic of x1 and x1a have changed. If the confidence level is 5%, then this one is significant. However, but for this one, if the confidence level is 95%, then it's not significant anymore. Just with these two results.
Do we put the signs, expected signs for this two variables, y?
No, because there's no literature review.
Yeah. So in this case, we see the both signs of the probability, right?
Okay. I mentioned here,
Yeah.
might reject the null hypothesis.
Yeah, okay.
Because I know it might be a negative sign, so I just say might reject, but maybe it do not reject if the sign is wrong. Okay, so here, just like I said, the coefficient has t statistics, and these are the same. And oh, okay. So basically, what this line means, the x2 still are not significant, even if there is a slightly changes between two sets. However, the x1 and x1a, only this part have chance to be significant to the dependent variable. That's all. Thank you.
Any other finding?
That's the only one, because all
That's
the
the
others
only
are very similar, as you can see.
Okay. All right. Okay. Thank you very much. Yeah, we spent only almost 1 hour to do the presentation. Well, last time make it shorter,
Okay.
but you need to summarize what you have done. Okay, to do the presentation. Okay, then how about we either yeah, you won't be the next one. Well, or we either one of you make the next presentation. Okay. Well, do we want to take a 10 minutes break, then do the presentation? Okay. Okay. Let's have 10 minutes break, okay?